All right, we are back to using the limit definition of a derivative to find the derivative of some more complicated functions. This first example will be finding that of a square root function. So there's a lot of pretty crazy algebra that gets tangled up in the middle of this. So that's why having this video will be nice, because you can pause it, slow motion. No, don't ever slow motion. Back it up, check it out, see if there's something that makes sense or doesn't make sense. So I'm going to start by officially writing again the limit as h approaches 0, and then this is that difference quotient, so it's going to be pretty long. I have to put the x plus h in here, so that's going to be the square root of 2x plus h plus 1 minus f of x itself, which is the square root of 2x plus 1, and that was all over h. So again, I'm just going f of x plus h minus f of x, that's a horrible x, all over h, and this is the limit as h approaches 0. And I'm jumping into notation. If this is f of x, then this is the derivative, so that would be what f of x is equal to. So really, this officially is the derivative is equal to the limit as h approaches 0 of this difference quotient. So again, if I were to just plug 0 in here, then this would just be 2x plus 1, and I'd get 0. Because they are subtracting each other, I put a 0 down here. 0 or 0 is no good. So I have to do some algebra. And so what I'm going to do is I'm going to rationalize the numerator. Now, often we're doing this process with the denominator when we have square roots in the bottom, but I'm going to do it to the numerator because this isn't going to work the way it is. So I'm going to multiply by its conjugate, which means I'm going to multiply by the exact same expression. I'm only going to change the middle from a subtraction to addition. So this part stays the same, 2 times the quantity x plus h plus 1 plus the square root of 2x plus 1. And if I multiply the top by that expression, I have to also multiply the bottom by that expression. And this is where it gets very cumbersome, because you have to write all of this. And I also know that you're probably saying, wait, I just put a square root in the bottom. That's a plus 1. That doesn't look like it, but it's a plus 1. And you're saying to yourself, hey, all these years you told me to get rid of square roots in the bottom, and I just put one in there. Don't worry about it. We're going to deal with it. Now I can FOIL these two, so it'd be the first times the first, and those two things are exact square roots of each other. So that means that if I were to multiply them, like I would if I multiplied anything that was the same square root as itself, it becomes squared. Square cancels the square root, so that just equals 2x plus h plus 1. If I were to multiply this one together, it would be a negative of these two square roots. And if I were to multiply these two together, it would be a positive of those two square roots. So they'd be actually exact opposites. So those two would cancel out. So that's me, again, crunching through this FOIL process. And in this case, the middle terms cancel each other out, just like if you have difference of squares. That's basically what I created here. So then I just have to go last times last. It's going to be a minus, because a minus times a positive is negative. And again, a square root times a square root. 2x plus 1 square root times itself is squared, so that comes out as 2x plus 1. Notice I'm putting in parentheses because I need it to subtract that entire quantity. Now the bottom is where the mess lives now. All of this is still down there with that h. So I'm going to put that in parentheses, and I'm going to 2x plus h plus 1 plus square root of 2x plus 1. All right, now I can do a little bit of cleanup on the top. I'm going to go this direction. I'm going to keep my limit as h approaches 0 because I have not applied it yet. I can distribute this, and if I distribute that, I would get 2x plus 2h plus 1. That distributes to those two. This minus sign I'm going to distribute. So I'm going to have minus 2x minus 1 all over top of this denominator. And I guess sometimes I don't rewrite the whole thing because I know I'm just carrying it forward. But because I'm putting this on very fancy video notes, I will be very official and demonstrate proper mathematics, and that would be including writing everything down. All right, now at the top you'll notice a couple things happen. I have 2x minus 2x, those guys cancel because that equals 0. I have 1 minus 1, that cancels. All that's left up there is 2h. Now that's it. Nothing else is up there. It's 2h plus 0 or 0 plus 2h. So the benefit of me scribbling all that out is, now I am kind of cheating things a little bit. If these are all gone, and this is where you can back up if you need to see why those are gone, but those are all gone now. All I have is 2h, and I have h times this mess, but that h divided by that h is 1, and that's where that h cancels that I told you was our goal every time. And so if that happens, I know things are pretty good because that just got rid of that 0 in the bottom that was giving me an issue. So I'm going to write f prime of x. I still haven't done this h goes to 0 stuff, but now I feel pretty good about it. There's a 2 right there on the top. Down here, I don't have to worry about that parentheses anymore because I got rid of that h. So I can just put plus 1. I do have a very long divisor down there, so 2x plus 1. And I can finally go to the point where now I can take this 0. I've only got one h, it's right there. So if I put 0 in for h, then, and now I've done the limit piece because I just put the 0 in. So now this is a 2 on top, and this is just 2x because that's a 0. So I would have the square root of 2x plus 1 plus the square root of 2x plus 1. And I don't know if you know this, but if I have 2 of these on the bottom, what I really have is 2 square roots of 2x plus 1. And guess what that means? Once again, I now have a 2 on the top and a 2 on the bottom, and they can cancel because they divide to equal 1. So I have 1 over the square root of 2x plus 1. And that is my derivative, which is the same as saying 2x plus 1 to the negative 1/2. Now I'm going to zoom back up here because I drew all over this, but I got a couple things I want to point out. And I'm going to erase this because this is very important, little commentary in here. That piece right here. What is the slope of the line tangent to f when x equals 4? So if I want the slope of the tangent line when x is 4, I want the slope at a value of x equals 4. So that question is the same as asking me what is the slope of f of x at 4, which is the same as asking what is f prime of 4, what is the derivative evaluated at 4. So all of those three things, 1, 2, 3, all are asking the exact same thing, and you're going to get them every way possible. But that means I need to figure out what f prime of 4 is. So I'm going to put 4 into my equation here. So I'd have 1 over square root of 2 times 4 plus 1, and 2 times 4 is 8. 8 plus 1 is 9. 1 over square root of 9 is 1/3. So the square root graph, if you remember, just in general, the square root graph without doing any of those transformations just kind of looks like this. So they're basically saying when at x value of 4, what is the slope of this tangent line? And it'd be 1/3. It's pretty shallow. All right, you are going to notice that there is one for you to try right here. And then again, the line tangent to f of x when x is 6 is asking what's the slope of f of x at the point when x equals 6, which is also asking you what is the derivative at 6. So pause this video, try this one. It's clunky and cumbersome. Just give it a try, see what you get. And I'm going to write the answer down in a second. Okay. You should have tried it. Video's on pause. I can tell you very quickly that the derivative to this function right here that we're looking at, without going through all of the insanity that you just went through, is going to be 3 over 2 times the square root of 3x minus 2, which is the same as 3/2 3x minus 2 to the negative 1/2. These are the same. This is what you would have gotten. I do want you to look for some patterns. Notice a square root in both of them ended up as a square root in the bottom. And then some things happened with other numbers in there sort of showing up. There seemed to be a 2 down there every time. At one point, this number ends up in a certain place. And then if I want to evaluate 6, 3 times 6 is 18. 18 minus 2 is 16. Square root of 16 is 4. So the slope, the answer for f prime of 6 is 3/8. So that would be the slope of this function at an x value of 6. And that's it. Enjoy.